So here's a question. It says it's about angular speed, linear speed. Earth travels about the sun in an orbit that is almost circular. So eccentricity close to zero. Assume that the orbit is a circle with radius 93 million miles. Its angular speed and linear speeds are used in designing solar-powered facilities so that they can tilt the mirrors to catch the sun the right way as the Earth is moving. A year is 365 days. Find the angle formed by the Earth's movement in 1 day. So let's think about this. I will think about it. The Earth moves a total. I'm going to do everything in radians because to get the linear speed, remember, linear speed equals the angular speed in radians per unit time, whatever that is, whatever the unit time is, times the radius. So I need radians. So in one complete orbit around the sun is 2 pi radians. So it's going to orbit 2 pi radians in 365 radians per day, 365 days. And that 2 pi over 365 or pi over, what is that, 180.5, whatever that is, 365 divided by 2. But that's the exact answer. The approximate answer, if I do 2 pi over 365, I can throw that into Desmos. And here I'll get rid of all of this stuff. 2 pi over 365 is approximately 0.0172. Approximately 0.0172 radians per day. Now you could, if you want, use that approximation for the next calculation. I'm just going to keep using the exact calculation. Now wants the angular speed in radians per hour. Well, look at the units. Radians per day. And if I multiply that by 1 day and divide it by 24 hours, the days cancel, I get radians per hour. So in other words, I just have to divide this by 24. I'm going to use the exact value, 2 pi over 365. 2 pi over 365 divided by 24 is approximately, this is approximately for part B, 0.000717. 0.000717 radians per day. Now it wants the linear speed. And again, the linear speed is the radians per unit time times the radius. So the linear speed is going to equal, it will probably come out right if you use this approximate value. I'm going to use the whole value, 2 pi over 365 over 24, and then I'm going to multiply that by the radius, which is 93 million. But if you did 0.000717 times 93 million, you'd get close. Let me see, I'll see if there's a rounding error here. Times 93 million, it comes out to approximately, I'm doing 2 pi divided by 365 divided by 24, which is the radians per day, times 93 million. And that equals, and remember, it's going to be, when you multiply the angular speed in radians per time times the radius, you're going to get whatever units the radius is divided by time. So this is going to be times 93 million is approximately 66,705, 66,705 miles per hour. And that's what it asks for in miles per hour. Now, if I use the already rounded, 0.000717 times 93 million, comes out to 66,681. So notice there is a little bit of a rounding error. So it's always better to use the whole calculation. Don't round in the middle of your calculations. This is good enough for the answer, round it off for the answer on that one. See, it comes out to 0.000717, but it's not precise. So use 2 pi over 365 divided by 24, which is radians per hour, and then multiply that by 93 million, you get 66,705 as opposed to 66,681 if you use that rounded answer for the last step. So in other words, 66,705 miles per hour for part C. That's the linear speed of the Earth in the miles per hour. Now I'm going to just take a look. I threw this into Gemini, and it came out with 66. Yeah, so it used the exact. Although it said it was doing 0.000717 times 93 million, it actually used the full value and showed 66. Well, it did 66,741. I don't know where it got that from. I'd have to try to figure that one out. Let me try it here. 0.000717. Let me try 25. 66,704. I don't know where Google Gemini got its answer from. It got 66,741,000. Where did that come from? Let me see what, did I do this on ChatGPT? Let me try it on ChatGPT. Let's see what it comes up with. You can't trust these all the way. Yeah, it came out with 66,681, which was the interim answer. So you got to be careful how you round things. I use the exact value. The radians per hour is 2 pi divided by 365 divided by 24. That's the exact number of radians per hour times 93 million miles. The radius of the Earth comes out to approximately 66,705 miles per hour.